Okay, for this question we just need a little bit of extra on the side here, and what we want to do is the following: to prove two consecutive integers, the product of two consecutive integers is even. Now, of course we can see that, right? 2 times 3 is 6, 3 times 4 is 12, right? So we can clearly see that. But let's just go prove it on the side anyway, and quite a formal proof. So to prove that n times n plus 1 can always be written as 2 times by some kind of integer, right? Always even. And the way we do this is we do not a little cheat, but a little workaround. Consider the two possible cases. Consider if n is even to start with. So if n is even, we'll write 2k here for n into 2k plus 1. Can we see that already? If n is even, then we've already got 2 times k plus 1, which is 2 into k into 2k plus 1, right? So that's definitely even. Now consider if n is odd. So we're going to grab this, right, and replace n with 2k plus 1. So you can probably see 2k plus 1 for the n here, right? And then this will be 2k plus 2. And can you see in this second bracket we can factor out a 2. So it's 2 into 2k plus 1 into k plus 1. Alright, so there we go. We've proved that the product of consecutive integers is always even. And now with that, you can go ahead and do question 20, and it will follow. Okay, let's go ahead and try and do this. Let's do it quite formally to prove an odd integer, 2n plus 1 squared. The result is always 1 more than a multiple of 8. Okay, let's go ahead and work on the left-hand side. Let's expand. That's 4n squared plus 4n plus 1. Well, that's a good start. Look, we've got the plus 1. I think factorising seems to make sense, right? Then we'll have a factor of 4. So definitely we've got that this is always 1 more than a multiple of 4. Let's keep going. Can you see what's going to happen in here? This is n into n plus 1. And lo and behold, this was the key, right? We've got to prove that n into n plus 1 is even. It is. So we can rewrite inside the bracket as 2m plus 1, which is identical to 8m plus 1. And we have proved what we needed to prove. Now it'd be fancy with a little rectangle. Sorry, square, right? There we go. There we go.